Hey, welcome back to the tutorial. In this video, we will learn about creating a project for Arduino Duo using Atmel Studio. And if you have any other flavors of Arduino, then also this video should hold good. Okay, so let's see how we can create our first project for Arduino Duo. So first, let's understand the features of the board. So Duo is the first board which is released by Arduino based on ARM Cortex-M based processor. So you can go to this link to explore more about Arduino Duo. You can see here Duo is the first Arduino board based on 32-bit ARM core microcontroller. This page has all the details required for you to get started with Duo. And let's see the technical specification of this board. This board is based on the microcontroller AT91SAM 3X80, and the operating voltage is of course 3.3 volt, and it has a SRAM of 96 kilobytes, and it can operate at maximum 84 megahertz. Okay, and it has a flash memory of, so where is the flash memory? Okay, here. So it has 512 kilobytes of flash memory, and this microcontroller should be able to run our FreeRTOS kernel, because our FreeRTOS kernel takes not more than 5 to 8 kilobytes of memory, and it has lots of various other features. I think you can go through this web page to understand more about this board, and there is a getting started guide here. So this getting started with Arduino Duo web page lists out all the things which is required to get started with the board. Okay, the board actually has two micro USB ports. So one is for USB communication. Okay, this will not be using, because when you are using some USB based programming, then you can utilize this port. You can convert this board as a flash device, or you can configure this as a USB device by porting a USB stack on it. So in those cases, this port will be helpful. And this micro USB is actually a virtual COM port which is used for programming. So you will program through this port, and this port is also used for serial communication. Okay, so because internally this port is connected to a UART, so that you can send and receive the data. And this board has lots of analog inputs and digital input output pins, so that you can utilize for your different applications. And this board doesn't have any onboard debugger. So this is one of the disadvantage of Arduino boards, that they don't have a debugger on it. But the boards from STM, okay, like STM Discovery or STM Nucleo, so all these boards have onboard debugger, okay, which works with SWD protocol. This onboard debugger itself enables you to debug the code. But for the Arduino boards, you have to buy an external debugger like Atmel IC or J-Link. The board gives the connectors. So this is a JTAG header where you can connect 10-pin JTAG based debugger like U-Link or J-Link or Atmel ICE to debug the board. And this is a 4-pin SWD connector. So either you can use JTAG or SWD protocol to debug this board. So most of the debuggers you see in the market, like J-Link, U-Link or Atmel IC, they support lots of debugging protocol like JTAG, SWD, SPI-by-wire, etc. Okay, so you need not to worry about that. So but only thing with this board is it doesn't give you onboard debugging chip, so you have to buy it externally. Okay, now let's see how you can install the drivers for the Duo, because when you connect the board, it must be detected in the PC as a virtual COM port. So the best way is the Arduino IDE has all the required drivers. Okay, so it's better to install Arduino IDE first. Okay, so even though we don't use Arduino IDE, let's download it and let's install that. So that will install all the required drivers for the Arduino boards. Okay, so for that you can go to this URL and download the Arduino software for your operating system. Okay, so if you have already downloaded and installed the Arduino IDE in your PC, then that would be fine. So no need to do this step. So this is only for the people who are doing it for the first time. This is a getting started guide, and if you want any help, you can visit this page where they explain lot of stuffs about installing drivers. Okay, for OS X, for Windows, and for other operating systems. So after installing the driver, when you connect the Arduino board to your computer, it will be detected like this. It will be detected as a programming port with a dedicated port number, okay, under the port section. Okay, so let's conclude quickly the important details of our board. So this is a primary board used in this course. So it runs with a MCU 8091 SAM 3x80. So that is a SAM family of microcontroller from Atmel, and the processor architecture is Cortex M3. Okay, and the maximum speed at which this microcontroller can run is 84 megahertz, and it has 12 analog input pins where you can apply analog voltages, and the flash memory is 512 KB, and the RAM memory is around 96 KB, and it has 54 digital input output pins. And please remember, there is a warning on the site that unlike most Arduino boards, the Arduino Duo board runs at 3.3 volt. The maximum voltage that the IO pins can tolerate is 3.3 volt. So applying voltages higher than 3.3 volt to any IO pin could damage the board. What they are basically saying is the digital IO pins actually can tolerate maximum of 3.3 volt. Okay, so don't apply any voltages more than that. Okay, so let's start our Atmel IDE, which we installed in our previous lecture. Just type Atmel. Great. So when you launch the Atmel Studio, it will always show you some documentation. So that means there are some getting started guide to learn about how to use Atmel Studio, and getting started guide regarding AVR development, and you can also download lots of Atmel Studio extensions like memory logger, terminal window, tracer, logic analyzer, etc. So you can explore more about clicking these links. In this video, let's learn how we can create a new project. Okay, first go to File, New Project. Okay, so now it will ask you what kind of project you want, whether it is a AS7 board project or executable project, a static library project, etc. So we'll be using a AS7 board project because we'll be using a lot of AS7 components of the Atmel Studio. And the nice feature of this Atmel Studio is even you can create Arduino sketch. Okay, and even you can import your sketch to Atmel Studio. Okay, so that's why this IDE acts like a nice replacement for your Arduino IDE. Okay, so in this course, nowhere the Arduino style of programming is used. We will just stick to normal C programming. Okay, so I will choose a GCC AS7 board project, and now give a name for your project. Okay, say it is a project 1, and Atmel is saying it will store your project in the default location, documents Atmel Studio. That's fine, no problem. And here you can enter the solution name. So there is a difference between a project name and a solution name. The difference is there could be multiple solutions under one project. Okay, think of a project like understanding microcontroller, and a solution may be understanding ADC, understanding a watchdog timer, understanding LED programming, like that. So a project can have multiple solutions with its own source files. So you can have a project one and you can have 10 solutions under that, each having its own separate main file. Okay, so let's give a name as project and a solution name as LED app. Now let's click OK. Now the studio is loading all the board's details. All right, so now you have to choose your device family. We are using, so you can either use select by board or select by device. Okay, so I will always go for select by device, and so select your microcontroller. So our microcontroller which is running on Arduino Duo is SAM3X, right? And the exact name is SAM3X8E. So when you click this, it will automatically show the supported boards. Okay, so that is the entry called Arduino Duo. So select that. At the right hand side you can see all the supported debuggers from this IDE. So the studio supports Atmel ICE, eDebug, JTAG ICE, mdebug, JLink, etc. So interesting thing is it doesn't support, so please note that it doesn't support ulink. All right, now let's click OK. Now this is creating a project. Great, so it has just created a project for us. The name of the solution is LED app. So here you can see it has created multiple folders for us, and this is our source directory. Okay, here this is your main source file where you are going to code your application, and it has also added 2 more folders like ASF. Okay, all the ASF related components will be stored in this folder, and all the configuration header files will be stored in this header file. You can see it has already created 2 configuration files for our board. Okay, one is a board configuration file where you can enable or disable macros, and a clock configuration header file. Okay, and the ASM actually consists of 3 main folders. Out of that, this common folder is related to common functionalities like services, utilities, board header file, etc. And the SAM folder is specific to your microcontroller. Okay, because we are using SAM based microcontroller here, it gives you some of the minimal drivers and board header files. So under SAM, you can check here, there is a Arduino Duo x.h. Okay, this header file actually contains all the Arduino Duo board details. For example, it will list out what are the LEDs and its digital pin numbers. It also contains the details about your push buttons, to which IO pin it is connected, and it also has the information about timers and PWM pins, all board details. Okay, everything it has. Okay, that is kept under SAM because this is a SAM specific header file, isn't it? After that, all third-party softwares will be stored under third-party, because third-party means something which is not related to Atmel. Okay, so for example, Kimsys is from ARM, isn't it? And PreArtos is from preartos.org. Now, apart from that, it has created ASF.h because we have chosen ASF based project, and then there is a main file where you will code your application. So that's how you create the project for your board using Atmel Studio. So in the next lecture, let's code a LED blinking application for our Arduino Duo board. See you in the next lecture.